Table still which number?
My dad taught me a trick until 20.
20.
Yeah.
So, okay. See, you guys are blessed to have the access to calculators even in the 10th or 11th grade. When I was small, or when your dad was small, those days. Hello, Ananya.
Hi.
Did I say your name right?
It's actually Anaya.
Anaya. Yeah. I was wondering if I'm still memorizing the names correctly or not. Okay. Here, Anaya. So now bear with me for 1 or 2 more classes, beta. I will try. Today I made that mistake. I hope I'll fix it by next class. Okay.
Okay.
Yeah. So Anaya is here, Kian is here, Vivan is here, and then Suchit is here in the classroom. And 2 more kids are supposed to join, Swecha and Marco. So what I was trying to do was, before we start the class, I wanted to do a quick check. How comfortable are you guys with tables? That's what I wanted to know.
Like the multiplication
Multiplication
table?
table, yeah.
I'm good at it. I'm pretty good.
Till which number? 10, 12, 14, 16?
12.
Till 12? Okay.
I think 1 to 22.
Till 22? Okay.
I can go to 20, but that's only if I can have a table to do it. But stuff I can do with my phone.
No, I don't want anybody to do calculation. It should be like, it should come like this. 17 5 is 85 without any paper. So let's see. Let's do that as a surprise exercise and see. Because again, math is a subject that I want you guys to play with, okay? So let's start with Suchit. No, it's okay with that. See, this
Alright.
I will make you guys play with math, okay? That's my goal.
Alright.
Okay?
Yeah.
Table till
20.
20, 15 5 is
Oh.
15 times 5, what do you call it?
What?
15 times 5,
15 times 5? Why am I blanking? 75.
75. 14 times 6,
14 times 6. Hold up. 84?
12 times 9,
Wait. No. 108?
7 times 8,
Oh, 56.
13 times 7,
7. Wait, can you say? 90. Wait. 91?
91. 17 times 8,
17 times 8. 156.
36.
Oh, 136.
Okay, let's check. Anaya, do you want to go next?
Yeah.
Okay, table till
What?
12. 12 times 8,
Wait. 92. Wait, 96?
96. 8 times 7.
Is it 56?
Don't ask me questions, just be confident. Even if you are making mistakes, nothing goes wrong, trust me. This class is meant for making mistakes. 7 times 9.
12 times 9?
7 times 9.
Wait, I cannot hear what?
7 times 9.
7 times. 63?
12 times 8.
96?
12 times 7.
84?
8 times 8.
64?
11 times 9. Did you say 99?
99.
Okay. Kian,
Yeah.
table till
15.
14 times 7.
14 times 7. 98.
12 times 7.
84. 84.
12 times 8.
96.
9 times 9.
81.
Okay. 15 times 7. So Swechha, today the kids are trapped with me. I'm doing a surprise check of tables because tables are the backbone for math. Okay? You're talking to the mute button, but I cannot hear you.
Multiplication tables.
Multiplication tables, yeah.
Like 2-digit or 1-digit.
Any number that you're comfortable with.
Okay.
I think number is about to come. Okay, so table till which number we want?
I'm good till 12 table.
Till 12?
Yeah.
Okay, so 12 4 jar.
12 forza is 48.
12 9 jar.
108.
9 9 jar.
81.
7 8 jar.
56.
6 7 jar.
42.
11 8 jar.
88.
12 9 jar.
You already told me that. 108.
Doesn't matter. I will not remember that. Okay. So it's about how quickly you are going to switch between numbers, how quickly you get the response. Vivan, you're the last one. 17 5 jar. 79 jar. 79 jar. 18 8 jar. Yeah, you do it. Okay. So, Marco, you are trapped. Now, when I say trapped, today I am doing a surprise check. I'm checking how comfortable are the kids with the multiplication tables.
Okay.
You know tables till which number?
Um,
10, 12, 14, 16,
I think 8.
8, 7, 8 jar. 7 times 8.
Wait. I don't know.
56. 8 times 9. 72. Yeah, so it's okay.
Bad.
No, it's perfectly fine now, okay? So see, the deal is we have to practice those tables. Don't spend a lot of time. Spend 5 minutes of your time once or twice in a week, and that'll be good enough, okay? Alright, so Anahita, I'm just doing a quick table check for the kids, okay? I'll take 2 more minutes and then we'll get going with what we wanted to learn. Table till, Anahita. Where did you go? Don't disappear. It's not that difficult a deal. Okay. Anahita got scared. Okay.
I had to close the door.
Yeah, that's okay. Table till
12.
12 9 jar.
108.
11 7 jar.
77.
8 8 jar.
64.
12 7 jar.
7.
12 7 jar.
90. Oh no, 84.
84. 2 3 jar.
6.
12 9 jar.
108.
Okay, good. So, see again, no big deal. It's all about making sure that we learn things. What is that?
I just found it.
Yes.
Okay.
Okay. So, Yaganya, can you hear me okay, beta? I know Adya has been struggling to join, keeps getting dropped off. Okay. I hope everybody can hear me okay. Everybody as in everybody. Anaya, Swechha, Anahita, Vivan, Kian, Marco, and Suchit. Everybody can hear me okay, right? There's
Yes.
not any problem with the network.
You talk really fast.
I'm talking very fast, so I'll go a little slow. And for that, I need a sip of water. So in the last class, I got a feedback that some of you were not really clear about what we did in the last class and why. Okay? And that's a fair point. I always need feedback to come from parents and from the kids. You guys are kids, okay? Even if you guys thinking you have grown up enough, no, you guys are still kids for me, okay? So, if there is something that is not clear, don't hesitate to ask. Swechha is trying to say something. Say something.
Nothing.
Nothing? Okay. No, you were scratching head. So I was thinking, okay, something is kind of bothering you. Okay, no. It's okay. Don't worry about it. Don't mark my words. It's okay. So, what we tried learning in the last class was about equations. What do we mean by equations and what does it mean to us? And Vivan, you were not in the last class, so I'm sure this is coming new to you as well. I will start from the most basic step and then we'll go gradually forward. Yeah? Anahita, you also had some doubts, right? I was kind of getting you stressed out. So some of the kids had doubts, so that's what came as a feedback to me, and I love that. If I'm saying 2 plus 3, easy peasy, 5. 5 plus 9, easy peasy, 14. So far, everybody okay? Anaya, Vivan, everybody okay so far? I'm sure you guys don't learn this, but still. I'm showing you guys how do you take step by step to climb up. So these are called constants. 5 was 5 when I was 2 years old, and 5 is still 5 even if I have grown to become a 49-year-old. These don't change. That's why they are called constant. Everybody okay? Now, life doesn't remain simple, unfortunately. Some complication comes into play. Now, if I say x plus 3, this is when we start thinking, where did x come from? Or if I'm in a playful mood, I will say a plus 9. From where did this a come? Right? These alphabets that you see that comes across, these are called variables. When you don't know about the value of something, that is when you put a name to it. Saying that, okay, I'll find out later. If I ask Anahita, how old are you? Anahita will say, I will tell you later. I will say, okay, fine. Let's assume Anahita's age is X years. When she tells me, I will plug in that value. That's the reason, okay? That's why these are called variables. It could vary. If Anahita tells me her age between today and tomorrow, it will be some value. If Anahita tells me her age after 4 years, that will be a different value, correct? It could vary with time, with whatever reason. That's why these are called variables. So algebra is all about dealing with knowns and unknowns. These are knowns or constants that will never change. These are unknowns that could vary. They are called variables. Good starting point so far? Everybody with me? Not speaking fast this time? Did a better job? Okay, good. Now, so that is what comes our way when we are dealing with some knowns and some unknowns. Look at this. Anahita told me, I will tell you my age after some time. I'm sorry Anahita if I'm picking on your name, okay? I know that Anahita's age plus 4, she tells me a clue that okay, my age plus 14 is 25. This is nothing but an equation. You have something unknown plus something known added together to get this outcome. This is nothing but an equation. This is the simplest form of an equation that we're dealing with. Loasita. Okay. So Ashita, when you were not there, we started talking about equation. Okay. So this is so basically when we move from a situation where we have some knowns and some unknowns resulting to some outcome, this is called an equation. This is your unknown or variable, this is the known, this is also known, and in between you have an equal to sign. So when you have an equal to sign representing some inputs and some output, that is called an equation. Everybody okay so far? So what we were grappling with in the last class was this. If I have a situation like this, x plus 12 equal to 27, I'm not talking about another anymore, okay? I'm talking about something else. So don't worry about it. X plus 12 equal to 27 versus a situation where somebody says x plus 2y equal to 55. This is a good situation to be in. From this I can find out the value of x, correct? Everybody can find out the value of x from this one? If I just give you this and say, okay, find out the value of x and y. Anaya, how difficult that would be?
For me, it would be difficult.
It will be difficult. Because this is what we tried to derive or determine as a conclusion from the previous class was that if I have something like this, meaning one equation with only one variable, it's easy to find out. When I have an equation with two variables, it's difficult to find out or solve for it. Yeah? If I have one equation with only one variable, it's easy to find out. Let's find it out. X plus 15 equal to 27, that means x will be equal to what? You will make this guy cross equal to sign. Yeah? It will become 27 minus 50. Whatever it comes to. 12, 14, 17, whatever it is. There is one sentence or one punchline of mine that kids hate me for, and that is, I don't care about the answer. Because for me, what is important is, are we clear about the process part of it? If we are clear about the process part, my answers will be right. If I'm not clear about the process, 50-50. You might go wrong, you might go right. Depends. Yeah? Anaya, is that okay? Okay, so we had one equation with one variable and we could find it out. Even if this x was not x, this was s, then also we could find out the value of this guy. Yeah? Same way. But when you are dealing with an equation with two variables, it might not be straightforward. Okay? If you are given only, let's say, even if you are dealing with the cutest cutest equation ever, x plus y equal to 5. Very simple, easy-going equation. I see Asita is right next to a food truck. Okay. So, but here, even if you are looking at the cutest, simplest, easiest looking equation, and I say, okay, solve it for x and y. I'll end up, if I try solving this, I'll end up losing a few more hairs. And then I'll have a very shiny bald head. Yeah? But on a serious note, you cannot solve for two variables with one equation. Is that okay?
With like a defined answer.
With a defined answer. Yeah. I mean, whatever we'll say, those will be guesses. So the next thing that we talked about in the last class was, when you are looking at any equation, x and y are two variables and they are bound by a contract. Say, okay, you know what? I'm x and let's say Vivan is y. So I and Vivan have done a contract, signed a document, say, okay, your value and my value together will be 5. And that we are locked in a contract, okay? We cannot breach that contract anymore. Now, I and Vivan got logged into a contract saying, okay, my value plus your value will be 5. I said, okay, how about me having value of 1? Vivan says, okay, we have to meet 5, so my value will be 4. 1 plus 4 is 5. I said, okay, my value will be 0. Vivan says, okay, so then I have to change my value to 5 so that my end result doesn't change. I said my value is 5. Vivan says, okay, then I have to go to 0. That is how this outcome doesn't change.
Wait, but aren't there like infinite possibilities because you could go to decimals?
Exactly. So I'm not, see this table, I'm limited, constrained by the space here. If I start scribbling on the wall and then on the floor, that wall, roof, there is no limit to it. What we are trying to say is, if I say this is 4, this will be 1. And we can just go on, 1.2, 1.3, 1.9, 2.6, whatever. Hello Adya, can you hear me okay beta? I know you were struggling to join. Okay. Jaganya, can you hear me okay? At least give me a thumbs up. I scared her again. Okay. So, when you have an equation with more than one variable, you are not able to get the perfect answer. Adya, today we are talking about equations beta, okay? So, if I have an equation with more than one variable, I am not getting a definitive answer. What I am getting is all the speculations that we can make. Anaya, switch, everybody with me?
Yeah.
So when you have one equation with more than one variable, you can contemplate all different answers that you could think of without breaking this contract. But you will not get one definitive answer. Like this case, x plus 3 equal to 15. Here you get only one value for x. Look at this, how many values of x you have already got. And if I had 5 more hours to waste, I would have gone on coloring the entire wall of this classroom. Yeah? I painted this garage, classroom, whatever you call it, a month ago. I certainly cannot dare to scribble on the wall anymore. So that's why I stopped here, okay? But the message here is, with two variables in one equation, you can have multiple combination of answers, but no one definitive answer. Anaya, Anahita, Kian, Vivan, Adya, everybody with me? Yeah? Don't be shy when it comes to asking questions. So far it's okay. So that is why I was getting you guys towards the situation that is it a deadlock that if somebody gives me an equation, say okay, solve it for x and y, I'll surrender. No, I cannot. We will not. We will say, I can solve it for you. Give me at least two equations with the same variables. Yeah? So if I have one equation with x and y as two variables, I will bargain to ask for one more equation at least. I'll say, okay, give me another equation. And that guy being generous enough says, okay, fine. Your other equation, 2x minus y equal to 17. That's a sigh of relief. We wanted to solve for two variables. What we need is at least two equations. That's a deal. Yeah? Vivan, saying something? Go for it. Everybody okay? Asita okay? Adya okay? So this is the deal that you have to strike with whoever is giving you the question. What happened, Asita? So here, I like everybody's expression here, but unfortunately we are dealing with the equation. So we will stay with equation. So here, with one equation, we cannot get a definitive answer. We can get options, so many options, but not one definitive answer. So we bargain for, say, okay, fine, give me at least two equations if you want me to solve for two variables. And this is the situation we have. Now, other person was generous, or whoever was giving the question was generous enough to say, give us the equation. Now we are again stuck. How do we solve for this now? We have two equations and two variables. How do we solve for x and y from this one? So that is where there are two methods. One is called method of substitution and second one is called method of elimination. You guys remember what I was blabbering about in the last class? Kian, does it remember?
No.
No? Okay, that's fine. Ashrita and Vivan will anyways not know. Adya will also not know because they were not in the class. But my humble request to you all would be, many times you will miss the class and that is understood for whatever reason. Please, even if I am not taken bath, I am not looking great in my video, please watch the video of the class to revise what we have done in that class. Okay? Whichever class you miss, just watch it. I mean, keep aside the preaching part, okay? Wherever I am unnecessarily talking, skip that part, and whatever I am explaining the concept, please revise it. So that way you'll find yourself closer to the concepts, okay? I mean, I'm not denying that I'll not explain things again, but leverage the video because that's the main purpose for the video, okay? Now coming back to this one. So when we have two equations with two variables, then we should be able to solve for it. And that's what we were talking about. There are two methods. One is called method of substitution, and second one is called method of elimination. So method of substitution and method of elimination. Any guess what I'm talking about?
Didn't we learn about substitution yesterday? I mean, not
Day before yesterday. Yep.
Tuesday.
Yeah, Tuesday. Yep.
We didn't learn elimination.
We did not learn elimination. So, but see, the thing is, I always say, English is the mother of math. Meaning, if you get the meaning of the word that you're dealing with, the terms, you'll be able to relate. So when I'm talking about substitution, method of substitution meaning some value is to be substituted somewhere. Let's look at what is that we are trying to substitute. If you look at this equation, x plus y equal to 5. If I take this equation and find out the value of x, let's say. So x will be what? 5 minus y. Yeah? From the first equation. Yeah? Yeah? Is everybody with me? Adya, Swecha, Kia? Yeah? So from this we found the value of x. And substitute this value of x into the second equation. That is essentially what the method of substitution says. That find out the value of one variable from one equation, substitute that in the second equation. So we found the value of x from this equation, which came out to be 5 minus y, and took this value of x and plugged into this equation. So this is 2x, 2 times x, whatever is the value of x, 5 minus y equal to 17.
Wait, oh, so we're just saying that 5 minus y is x.
Yes, so this is what we got, right?
Yeah, just like a placeholder.
It's a placeholder. Anaya, Ashrita, am I making sense to you guys better? Yeah? So substitution says, substitute a value from one place into another place. Took the first equation, from that we found the value of x, plug that value of x into here. If you like y more, you find the value of y from this equation, plug it in here. But I'm not trying to confuse you guys. Take one example. Found the value of x from the first equation, whatever you got, take this value and plug it here. Now let's break the brackets open. 2 times 5 is 10. 2 into minus y becomes minus 2y. Minus y equals 17.
So isn't it just minus 3y?
Yeah, so 10 minus 3y equals 17. So minus 3y will be 17 minus 10. So minus 3y will be equal to 7. So y will be equal to 7 divided by minus 3.
Wait, how do we solve that?
What is that?
So how do we solve 7 over 3? Minus 3.
Minus 7 by 3. Wherever I have this value, let's see if I'm plugging it here. Now, so are you okay with this journey so far?
Yeah.
Everybody? Yeah? Okay, Anahita, Swecha, Anaya, Adya, Kian, Vivan, everybody? I said no. Okay, alright. Okay, so here, see, that's the thing. I get super excited when I meet you guys, when I'm dealing with math, right? So you'll see that happiness on my face. So here, we had two equations. We are talking about the method of substitution. Took the value, derived the value of x from this equation and plugged in that value here. That's why we are calling it method of substitution. And we are not done yet. By doing this thing, we got this and we found the value of y. We will again substitute this value of y in any of the equation. Let's pick up this one. So x plus y. Y is minus 7 over 3 equal to 5. So this becomes x minus 7 over 3 equals 5. That means x equals 5 plus 7 over 3. It's a situation of fraction addition. So,
Wait. Oh, never mind.
yeah.
Yeah, never mind.
So you can multiply this by 3, divide this by 3. So this becomes 15 over 3 plus 7 over 3. That is 22 over 3. So you got the value of x equal to this, value of y equal to this.
Wait. X is equal to 7?
Now, x plus y equal to 5.
Yeah, but how does it say x equals to 22 over 3?
So here we calculated that, right? So you should look at this.
Okay.
We got y equal to this, and we are substituting this value in either of the equation. Okay, so we are substituting it here. So this equation says x plus y equal to 5. Now we know the value of y. We are plugging in that value here to x plus y.
Okay,
Yeah?
I think I understand because it's like that one's negative, so wouldn't it like subtract?
So
Y?
subtract is like this, negative value.
Yeah.
So plus becomes
Oh yeah, so that makes sense because that's
Yeah.
7 and then you take away 2.
Yeah.
Yeah, I get it.
Is everybody with me or I am teaching myself? Everybody with me?
Yeah.
Am I making anybody sleepy? I see Kian ready to sleep anytime. No?
I had a class right before this.
Okay. So Anaya, Swecha, Ashita, Adya, everybody okay? You got it? Okay. So this is called method of substitution. Now you should look at it carefully. In the beginning I said that if I have an equation like s plus 2 equal to 5, meaning one equation with one variable, we can solve it. By doing all the circus and drama, what we got to was a situation where I have an equation with one variable now. Yeah? So the same thing we continue with. Method of substitution, what we did, we picked up the value of one of the variables from one equation, plugged into second equation, and then we got to a point where we could translate this equation to one variable equation and we found the value for it. Now look at this. I can do the same thing or similar thing for the method of elimination also. Or let me not say it that way. X plus y equal to 5, 2x minus y equal to 17. That's what we have. Okay? Now, method of elimination is a technique that helps you get rid of one of the variable. You are eliminating one of the variable. How do we do it? Simply add these two. Simply add these two in this case. You have one positive x, one negative x. One positive y, one negative y. When you add this one, so you have 1x and you have 2x here. It becomes 3x. Plus y and minus y becomes 0y. Equal to 17 plus 5, 22. You got to a point, you have one equation with only one variable. So 3x equal to 22, so x will be equal to 22 by 3. Was it? Vivan, don't do it. If you scratch your head a lot, this is your future. I'm just kidding. Okay. before I make you guys stressed out. So there are some rules of thumb that I want you guys to understand. Before we talk about method of elimination, okay, there are certain things that we want to understand first, conceptually. Forget about the method of elimination for next 5 minutes, 10 minutes, 20 minutes, whatever it is. Okay? Forget about the method of elimination. Is that okay? What we'll do? We'll play music, start dancing? No. Okay. Alright. So, if I have an equation like x minus y equal to 15, if I multiply this equation with 4, this is the same equation.
4x minus 4y.
So 4x minus 4y equal to 15, 15 into 4 is same as this equation. When you have any equation, this is a rule of thumb. I mean, I'll decode this further, okay? When we talk about coordinate geometry, I'll explain that also. If you have any equation, it is okay to multiply or divide each and every term by one number, and you're not changing the behavior of the equation. So if I have an equation like this, I can multiply by 4, I can multiply everything by 2, I can multiply everything by 7, I can divide the whole thing by 2 also. And doesn't change the behavior of the equation. Is that okay?
Yeah.
Yeah? Let me prove that. Because otherwise you guys will never trust me. And that is where I will fail if my kids don't trust me. Okay. So I have an equation x plus y equal to 2, let's say. Okay. What I'm saying is, if I multiply this equation by 2, I'm not changing it. Yes.
I have a question. Wait, what are we doing now?
I'm saying that if I have any equation, if I multiply that by any number or divide that by any number, each and every term,
The product's the same?
the equation doesn't change its behavior.
My math teacher usually does it like this. Is there any difference? Like maybe in the middle of it.
No. No, this is, if it says like, it puts like this is not equal to. I don't know what this line below this means. I have not seen that before. So if I have, let's say, an equation like this, what I'm saying is, if you multiply this equation by any number, the equation doesn't change its behavior. And I will do that in a layman way, okay? Now let me do that. When I have an equation with two variables, I will get a combination of answers, right? Combination of x and y values. This one, it becomes 2x plus 2y equal to 4, correct? Now let's look at what kind of table these equations are making for me, for x and y values. Let's pick two values, okay? Just to be mindful of the time.
0 into...
When I put x equal to 0 in this equation, what is the value of y? 2. When I put x equal to 1, what is the value of y?
1.
1. So far this is okay, everybody? Anaya, Swechha. Okay. Now come to this equation. I had the same equation, we multiplied by 2. Let's put the value of x equal to 2 here also. When I put x equal to x equal to 0. So 2 into 0 plus 2 into y equal to 4. That means this is 0 to y equal to 4. Y equals 4 over 2. When x is 0, y is 2. When x is 1, what happens in this case? When x is 1, that is 2 into 1 plus 2y equal to 4. That means 2 plus 2y equal to 4. That means 2y equal to 4 minus 2, that is 2. So 2y equal to 2, y equals 2 over 2, that is 1. Isn't this magic?
Wait.
Yeah? So see again, I was picking up the lamest way for making sure that we are all convinced as a group that if I have an equation, if I multiply that by any number, my behavior of the or the possibility of the solution that I will get will not change. And we pick this equation, put two values of x and y, 0 and 1. For x, we put two values of x, 0 and 1. We got corresponding value of 2 and 1. When we multiply this whole equation by 2, whatever we had, for this also we tried creating the same table with value of x equal to 0, we got y equal to 2, x equal to 1, we got y equal to 1, which matches with this one. So basically what's happening here is, when I am having an equation getting multiplied by any number, my possible answers or the combination of answers don't change. Swecha, Anaya, Asita, Ivan. I will let you guys process this information, okay? This is very important. I want this concept to get glued, injected in your brain without hurting anybody. Because you will eventually end up playing with this. So, tell me, what's going on in your mind right now?
I'm getting like the concept, but like, is there any way you can make like the board, I don't know, maybe write in bigger font or something?
Right. So anyways, I mean, you can, I will use a bigger font maybe going forward, but because I have to do the comparison side by side, that's why I will use the smaller font. Okay. But and when you look at the video, right, video will be much clearer than what you are seeing online. But what I'm trying to convey you guys is that if you have any equation, now I'm just trying to cement the idea that if you have any equation, you can happily multiply the equation by any number or divide the entire equation by any number, and you're not hurting anybody. You're not hurting the behavior of the equation. You're not changing the possible outcome of the equation as well.
You can even subtract or add, right?
No,
No?
that will be a problem. Multiplying or dividing is okay. Subtracting, see, look at this. X plus 3 equal to 15. If you're subtracting, let's say, minus 12 here and minus 12 here, this might be fine. But when you're dealing with multiple variables, it will go wrong.
Okay.
Yeah? So there's a concept called equivalent equation, okay, or same equation. You can always pick any equation and multiply that by any number that you want to multiply or divide, and you are still fine. You're not going to change the behavior of the equation. And why I'm stressing on the behavior of the equation, because this equation, what is the purpose this equation has? Guys, that is very lightweight. Make sure that you guys don't fall, okay? Because it topples sometimes. No, I mean, it will not topple. I'm saying just be a little careful with the movement of that. Because it's very lightweight, right? So, to come back to this one, why are we solving? What are we doing with any equation for that matter? Any equation. You have some knowns, some unknowns. Your only objective is to find out the value of the unknowns. That's it, right? So these are all techniques, good or bad, to find the or add method to the madness. If you have to find out value for this one, you created this table. Oh, I am not getting a point blank answer, but I get a combination of answers. Then we tried using method of substitution. We'll talk about method of elimination also. But before we go there, we are saying that okay, we are just decoding the behavior of the equation. If I have an equation, if I pick an equation, let's say you guys don't like the number 2. You guys like the number 13, triskaidekaphobia. Multiply. It remains the same. Yeah? So, Swecha, am I at least reaching you guys, or I'm not being successful yet?
Yeah, I'm able to get it.
Anahita, how about you, beta? you following it so far? Is it making sense?
I a little bit understand the substitution one.
So, okay, no. Wipe it off. Don't worry about substitution method. Right now,
This makes sense.
yeah. So, see again, these are the pieces that will put together to connect the dots. So here what I'm saying is, don't see, when I'm talking about equation or multiplying equation with any variables, I know if you have some backlog from previous concept, don't think about that, otherwise this will also not go inside. Okay. So we'll talk about that. Okay, method substitution is not done yet. We will come back to it. We will deliberate that, we'll muddle the water enough. Okay. But what I'm trying to say here is, if you have an equation, you are fine to multiply that equation with any number that you like. Right? My favorite on given day is 7. Some of you might have 4 as a favorite number. Some of you might have 2 as a favorite number at a given time, depending on the temperature of the day. Yeah. So you can choose the number that you want to multiply with or divide with, and you'll be fine. Now, everybody must be thinking, why we're talking about this behavior at all? Because this is going to be an important ingredient for us to deal with equation. So now one rule of thumb that we have seen today is that if I have any equation, I can multiply with any number, each and every term of the equation by any number, and we'll be fine. It's okay to multiply all the terms by a number or divide all the terms by a number, and we'll be fine. Is that one line stored in your hard disk? Everybody's hard disk? Okay. Now, next punchline is, if you have two equations, okay? Let's say you have an equation x plus y equal to 5 and x plus 2y equal to 15. Okay? If you have two equations, you can deal with them any ways you want. Meaning, you can say, okay, I want to add these two equations. You can just add them. It becomes 2x plus 3y equal to 20. It's okay. This gives birth to another equation actually. Okay? Related to this. Or you'll say, okay, fine, I want to subtract this equation from this guy. So x plus y equal to 5. I want to subtract this guy from this equation. Okay, go ahead and do it. Nobody is stopping you from doing that. Minus, minus, minus. X and x gets 0. 2y minus y becomes y equal to 10.
Why was it 10? Is that elimination?
We did that by mistake.
Wait, that's it?
Yeah.
It's kind of easy.
Oh, let's see.
So, again, see, the concept is always easy. Problems might get a little tricky. So, what I'm saying is, there are two concepts that I want you guys to store in your hard disk where it doesn't get deleted ever for the rest of your life.
Wait, but how do you know to... Oh, do you divide 15 by 3 because there are 3, like x and 2?
No, I did not divide.
Wait,
I had two equations. What I said was, if I have an equation, I can multiply with a number, it will be fine. If I have this equation, I can multiply this also with a number, it will be fine. That was the first concept. And this is the second concept, that if you have two equations, you can add them together, you can subtract one from another one, you can multiply one with some number and subtract from another one, that also works. That gives birth to a third equation. Okay? You can play with them, depending on the situation.
So y equals to 10, does it x equal to negative 5?
Maybe. Yeah, that's what it will be. So two concepts, I'm repeating myself, okay? Two concepts. We will kind of crush these two concepts for solving every problem that we'll solve hereafter. That if you have any equation, you can multiply that equation by any number, you'll be fine. Second is, if you have two equations, you can add them. So you can subtract one from another one. You can multiply one equation with something and then subtract from another one. You're fine. You just end up creating a new equation. That's it. These two concepts, can I assume that at least you guys heard me, okay? Now, I will show you what I am wanting to show. Now, if I have an equation x plus y equal to 3, x minus y equal to 2, and if I have to solve for these two equations, as I said, you can add the equations, you can subtract the equations, and that gives you a different flavor. Here when you see a one positive y, one negative y, you know that if I add them together, y will disappear. Yeah? When you have a positive y, one negative y, you know that when you add these two equations, y will disappear. Add them, x plus x, 2x, plus y minus y, 0y, that is as good as 0, equal to 3 plus 2, 5. What you found? X equals 5 over 2. So this is the method that is called method of elimination, where you are using your concept of multiplying equation, subtracting, adding equation to eliminate the variables, get to a point where you are left with one equation with only one variable, and that gives you a value for x, and then you plug in anywhere, you get the corresponding value of y also.
Wait, so what if you have in one equation you have like 2x?
I will show you. I'll show you guys. I'll show you. So is this part okay so far? Elimination is like going for the kill. You are trying to kill one of the variable so that you are reaching to a point where you have one equation with one variable. That is your ultimate goal. Now look at this situation. Let's say if I have equation like x plus y equal to 15 and 2x plus y equal to 10. Okay? If I add them, I will still have 3x plus 2y. Yeah? I can subtract this guy from here. Subtract this equation from this equation. Meaning I will put x plus y equal to 15 here and subtract this guy. Minus, this becomes minus, this is minus. So y and y will get cancelled out. So I subtracted this time. And then we got the value of x and we can plug it anywhere. If I had a situation like 2x plus 3y equal to 10 and x plus y equal to 15. Like I said, you can multiply any equation with a number and you will be fine. So here if you have 2x and you want to get rid of x, what you will do is multiply this whole thing by 2. It becomes 2x plus 2y equal to 15. And now you subtract this equation from this equation and see what happens. So this 2x will get nullified. It becomes y equals minus 5. So it becomes a combination of two. I know this is a little daunting. Yeah? That's why I call you guys kids. Now think like a child. Like a child, okay? Child as in, you guys are child, I'm saying younger version of you, okay? See, I'm seeing a younger version of you all. What I'm trying to say is, let's say, if you have 5 and you want to get 20, how will you get to that? You'll say I can multiply 5 by 4 and get 20. Or you will say I will add 5 plus 5 and then multiply by 2 to get 20. Yeah? These are different combinations. You can multiply by 4 also, yeah, Asita, like you're saying. Yeah? Yeah. So there are different options. So likewise, when you had a situation like this, you are trying to find out how do I get to a situation where I'm able to eliminate one of the variable. I can multiply this whole thing by 2 and then subtract this equation from this one, x will be gone. I can multiply the whole thing by 3 and then I can subtract, y will be gone. So that is where that favorite concept of mine, this comes into play. Now let me see who all are ready to cry. This is my favorite concept, I call it RAM. And this RAM, if I put a story around it, I know Kian, Vivan, Adya, Anahita has heard it enough, Yaganya also. Not sure about Swechha do. This is their story behind this. It says, who wins the race depends on who ran the best. See, they're already crying. Okay? And what it means is, this R stands for read. When you have a question to solve, read the question a couple of times. Stare at the question. Dig all the information out of it. Then A stands for analyze. And N stands for Nike. What does Nike say? Just do it. So, when you have a problem to solve, read the question enough, once, twice, thrice. Then you start putting your thoughts around it. Okay, this is the question, this is the information I have, this is the approach I will take, this is the formula I know. And then when you have created your blueprint for solving the problem, then you call out Nike. Simplest message to you all is, when you have a problem to solve, don't jump onto solving it immediately. Analyze. Think about it. Make your plan, make your blueprint before you try solving it. Because in an exam-like scenario, when you are constrained by time, you have only 2 hours or 3 hours for solving X number of problems. You waste 10 minutes by taking a wrong approach for solving a problem. Recovery would be very difficult. The time that you lose going down the wrong path is the time lost. You might end up getting less time for solving the rest of the problems. That's why doing that in a methodical way, picking up the right approach from the beginning, even if it looks like you are putting extra effort for reading and analyzing, you are assured that you will not take the wrong path and you will not waste the time that you are not wanting to waste. Was that a great speech? Anahita, how many times you have heard this from me? 20 times? Okay, keep a counter on, but regardless of how many times I have told this to you guys, the idea is this: we should get tuned to following this approach, because that will make your whole alignment towards math very different from what it would be otherwise. Yeah? Swechha, Kylie. Swechha must be thinking, that's been less than a month and I have heard this rant thing so many times. But this is how it is. The idea is to make sure that we get used to certain ways of solving problems or approaching problems. Because if I tell you guys all the concepts that I need to teach you guys, I can teach that in from 2nd grade till 11th grade in less than 2 years. Okay, less than 2 years. But then it's not just about rushing for completing things. It's about those things becoming part of our muscle memory. Yeah? So, Asita is thinking, man, this old man is giving a lot of preaching. Okay. Alright, so, also in that, what did we learn? We talked about what is an equation, what does it mean to us. Then, what is an equation with one variable? Very easy to solve. When you have an equation with more than one variable, you need as many equations. And when you have, let's say, equation with 2 variables, you need 2 equations. But is it straightforward to solve it? No. That is where there are 2 methods to solve it. One is called method of substitution, one is called method of elimination. And substitution, we just solve one problem. And I know there are still some doubts. Method of elimination, again we just touch the surface of it. But what we did was, we looked at the key concepts. How do you deal with the equation? If you have an equation, you can multiply, divide the equation by any number and you'll be fine. You can add a couple of 2 equations, you're still going to not disturb the whole ecosystem. And we'll use these 2 concepts for solving problems relating to method of substitution or method of elimination. And it's not that you have to choose, I mean you are constrained by any option. You can choose any of the options that works for you, which you are comfortable with, okay? Many times I found method of elimination easy, many times I find method of substitution easy. So we just need to have both the method with us and we'll apply them. So for now, I will give you guys some assignment, okay? After the class. It will be 7 or 8 problems that I want you guys to try and struggle with them. Struggle with them. And then in the next class, we will see where the struggle is and how do we make sure that we are more confident with application of these concepts that we have learned. Okay? So Today's assignment that I'll send you guys will be a bit of a ride. Don't get scared. Break your head with that. And be assured that this is meant for scaring you guys. Halloween is over, but after effect is still there. Okay? Anaya, are you scared with that? Little bit? No, don't be scared. This class is meant for making mistakes. We'll make mistakes to learn things. Okay? Alright, have fun. Asita is waiting for me to say good night. Alright, bye everybody. Bye bye.
Bye, sir.
Bye bye, bye bye, bye bye, bye bye, bye bye.